Sprinkler Talk again on a Thursday morning at 10 o'clock. So hello if you're watching me live, and hello if you're watching me on YouTube. So all of our presentations are uploaded onto YouTube a couple of weeks after they go out live. So they're going to be there as a reference to kind of come back to whenever you want to on a particular topic. So today is episode number 41. And this is part 2 of what I started last week on rules on obstructions. So in part 1, we looked at what I would consider the most basic of obstructions, which is when you've got a ceiling grid. I suppose the number one sort of basic obstruction is just walls. But I didn't count those in place. You've always got to match the sprinkler head spacing to what walls you've got. But yet sometimes there are ceiling grids, so false ceilings, and generally speaking, sprinkler heads are placed in the centre tile, and obviously that restricts you quite a lot in terms of where exactly they can be placed. It means they've got to be normally on a 600 by 600 grid. Which can make design quite challenging, especially then when you factor in other services. So I gave an example where we had some lights. So some of the ceiling grid was made up of light units, so we obviously couldn't place sprinkler heads in there, so we had to move them somewhere else. We then also looked at what's commonly called the beam rule. So this is where your ceiling isn't flat. So again, depend on application. If we're talking about an office or a shopping centre, somewhere that is got basically plasterboard ceilings, then you've got a nice flat ceiling to work with. Voids, we've talked about voids in a previous episode. I can't remember which one it is off the top of my head, but there are rules on when you would place sprinkler heads into ceiling voids. But smaller voids generally wouldn't require sprinkler protection. When you've got a nice flat ceiling, of course there are no obstructions there. But if your ceiling has supports inside, so you've got beams or changes in height of that ceiling, these can all be obstructions. And so we talked about how sprinkler heads are placed in regards to beams in particular, supporting beams. We don't want them too close to the beam because that's going to interfere with the discharge pattern of the sprinkler heads. That's the main thing that we're looking at is how the water is evenly discharged onto the fire. So we don't want anything that's going to affect that. Which is why, going off on a tangent here, but that's why we want to check if there's storage too close to the top of the head, for example. Again, that interferes with the discharge of the water. So that's, again, why we check for that as part of our maintenance and servicing of our sprinkler system. But anyway, today, part 2. Let's get cracking. So, just again, a reminder, what is an obstruction? So I've just kind of talked about that already, really. Things other than walls and ceilings which affect the layout of sprinkler heads away from the preferred placement. So I started off last week by showing you like the perfect room where we can get our sprinkler coverage to the maximum spacing that we can have. Obviously, in real life, that is pretty rare that would happen. So let's look at the platforms and ducts now. So these are could be cable trays. They could be HVAC ducts, so taking hot and cold air around the building. It could be pipes. So it could be gas pipes. Could be water pipes. Could be, say, electrical bits and bobs that are going around. So there's always going to be lots and lots of different services within our building environment. So how are we going to sprinkler protect these? Are we going to go above and essentially ignore the obstruction, or are we going to go below? Well, that depends on the shape, the size, and how far away it is from a wall. So I'm going to be going through that now. So we have this statement here, which can be found in BSEN 12845, which is 12.4.10. So this has got sort of 4 rules for all platforms and ducts. So there are going to be times where you're going to have to use a bit of common sense, because it only recognises rectangular and circular as 2 different shapes. So, you know, if you've got a slightly different shape, then say you're going to have to use common sense as to which one we're going to go for. Again, this is an example here, I feel, of they've done a great job of condensing down the rules into just 4 bullet points. But for me, it's a little bit confusing in terms of what exactly these rules are saying. So I'm going to go through it and give a few examples for you. So first of all, there's 2 rules for rectangular obstructions. So here I've got 3 rectangular platforms or ducts, A, B, and C. So first of all, A is more than 800 millimeters wide, and it is less than 150 millimeters from the wall. So this one would require sprinkler protection underneath, okay, because it is large and it is close to the wall. B is between 800 and or it should be 1,000, my mistake. So yeah, between 800 and 1,000 millimeters in width, but it is more than 150 millimeters from the wall. So in this instance, it would not need sprinkler protection underneath. C is larger than 1,000 millimeters or 1 meter, so it would. So what I would say to you is that if it is smaller than 800, then it will not require sprinkler protection underneath in any circumstance. If it's greater than 1 meter wide, then it will require sprinkler protection underneath in all circumstances. It's only between 800 and 1,000 that we start to get into this kind of area, kind of, well, how close is it to the wall? So yeah, if it's closer than 150 millimeters from the wall, then it will need sprinkler protection. If it's further away, then it won't, between 800 and 1,000. So that for me is a more simple way of explaining the same thing. But so yeah, so if it's small, then we can just basically ignore it. Yes, we're going to lose a little bit of our discharge through the water. If it's very wide, then obviously it's a bit like a ceiling, so we need to put a head underneath. Same for similar for the circular ducts. So these can be a little bit larger. So you can see that the principles are the same, but the numbers are a little bit bigger, and this makes sense, based on the shape. There's going to be more water. There's less obstruction with a circular object than with a rectangular object, because of the way in which the water is discharged. So that's recognised here. So again, I've got my 3 circles here. So this first one, is more than 1 meter. In diameter, but it's closer than 150, so that would need sprinkler protection. The second one is greater than 1 meter, but less than 1,200. It's further than 150 from the wall, and therefore it wouldn't. And then my final one is greater than 120. So as I say, the text can be a little bit confusing to kind of figure out what's going on, but again, same rules apply. If it's less than 1,000 millimeter, if it's less than 1 meter, don't worry about it. If it's more than 1 meter, so in between 1 meter and 1.2 meters, then it depends how close it is to the wall. If it's close to 150, then it will. Otherwise, it won't. If it's greater than 1.2 meters, then it will in all circumstances. So that's, again, hopefully a more simple way of understanding what those rules are saying. And then just to kind of talk again, I've spoken about this kind of thing in the past, is that when it says no, when I put an X there, that means that it's not required. Okay, it doesn't. You can, of course, put a sprinkler head underneath, but yeah, it's not required. So it's not a case of you mustn't. It's just it's not required. Another couple of things to go through here. So first of all, ceiling openings. So where we have ceiling openings around escalators and stairwells, then we want to increase the number of sprinkler heads there. So we're going to increase the density. So there's a rule for that. Again, you can pause the screen later on, or you can have a look in the British Standard to find that rule. Canopies, so 12.4.4 is talking about canopies. So again, we want to make sure that the sprinkler heads are kind of close to the edge of the canopy. I was thinking, is this an obstruction or not? But it seemed like a good place to plonk that rule in. And then last one here is columns. So where we have a supporting structure that's coming from the floor all the way to the ceiling. Again, this is going to affect the discharge of water. It's going to kind of get in the way. It's not a wall, but it is still going to affect the sprinkler discharge. So in this instance here, if we want to place a sprinkler head closer than 0.6 meters to one side of a column, then we place another sprinkler head on the opposite side within 2 meters. So I've given you a diagram there. It's sort of showing what that might look like. So obviously in the diagram on the right-hand side of the screen, we would like to put a sprinkler head right where that column is. If we were doing sort of normal spacing, that's where we put our head. But we can't because there's a column in the way. So we're going to put one sprinkler head either side of that column. So the sprinkler heads aren't going to wet each other. They're not going to sort of interfere, but we are going to get coverage all the way around that column. But say 0.6 meters is quite generous amount of space. So if we were clever, then we'd probably get away with not adjusting the sprinklers or not adding another head. So yeah, there are other ways in which we could arrange those sprinkler heads to bring the total number down by one if we kind of just back them off to more than the 0.6 meters, then we can get to the stage where we can basically ignore the column. But an extra sprinkler head is not really a big deal. Obviously, designers are always looking to reduce the number of sprinkler heads. It kind of proves that that they kind of know what they're talking about and that they're kind of doing a good job. It obviously does reduce installation costs at the end of the day, and it's a commercial business. But like I say, one extra sprinkler head, just a few pounds, bit more pipe, a little bit more time in installation. It's not going to make a big difference really. But I guess over the course of a whole project, if we can save 100 sprinkler heads, kind of one in each room, then obviously it's all going to add up. Okay, so that's it for today. That was I kind of feel like that topic was too much for two presentations. Too much for one presentation, but not quite enough for two. So yeah, that's again another bit of a shorter one this week. So next week I'm going to be looking at sprinkler alterations without draining down. So since we've got a little bit of extra time today, I'll just explain a little bit more about what that is all about. So when we want to do anything to our sprinkler system, if we want to drill a hole to within the pipes, then we need to drain it down. I guess I'm talking about wet sprinkler installations. If it's a dry installation, then you would still need to take precautions, because if you were to drill into the dry pipe work, then of course the air is going to be expelled, and that's going to be like a sprinkler head in operation. So the alarm valve will trip and the water go in. So we can't just crack on with a dry installation. But yeah, most commonly we're talking about a wet installation. So yeah, we're going to have to actually get the water out of the pipes first, then we can drill in and we can make our alterations. But there is a way of doing this without draining down, and that's going to save a lot of time, it's going to save a lot of water, and ultimately it saves money by saving time. So yeah, join me next week when I will talk about that. So we've got a question here. Do contractors use the same measurements or use software to cover the statutory areas? Not 100% sure what you mean. Sprinkler designers can use obviously a pencil and paper. They certainly did back in the day. They get the architect's plans, they put them on their table, and yet they get a pencil and a scale rule, and they will plan where the sprinkler head's going to go. Most designers now would use some kind of software to do that. So it could be AutoCAD. I certainly learnt using AutoCAD to place the sprinkler heads. So you can obviously check the distances, you can move them quite easily. You can place a sort of discharge circle over the heads. So that's quite useful to kind of check that you've got the correct coverage in different places. You can put these sort of circles over the sprinkler heads to see what the coverage is like. But yeah, there are lots of other different software packages out there which will place sprinkler heads. And they've all got a sort of a degree of intelligence kind of built into them, certainly for calculating frictional losses and for calculating the kind of hydraulic calculations. But I don't think I've seen any software that will kind of automatically place sprinkler heads around obstructions sort of reliably. I'm sure there's software that would do it, but I would definitely be wanting to check it all first before I sign it off. Yeah, but if that doesn't answer your question, then do give me another message on the chat. But I mean, yeah, cool. So yeah, any software that is using any kind of automated placement is going to be taking the rules, the measurements from the book. So even if you're doing it by yourself or you're using the software, the rules should be the same, and therefore the outcome should be similar. All right. Okay. So thanks so much for joining me this week, and hope to see you again next week, when we're talking about how to perform sprinkler alterations and maintenance without draining down. Okay. Thanks a lot. Bye-bye.